are 6 different books arranged on a row on a shelf. In how many ways can the books be arranged if A, there are no restrictions at all, and B, if books A and B must be together, so they must be next to each other. So we start with A. So basically this is a very simple principle. The number of ways you can arrange, a number of different distinct arrangements of 6 different objects is 6 factorial. So the reason for that is because you've got 6 spaces. For the first space, you've got 6 possibilities. The second space, once you've got 6 books available for the first space, then you've got 5 books available because you've already filled the first space, then you've got 4 available because you've already used 2 books, and then 3, and then 2, and times 1. And then the fundamental principle of counting tells you that for successive events with different number of ways they can occur, the total number of occurrences, you multiply them all together. So this is just 6 factorial, which is, what is 6 factorial? Well, 6 times 5 is 30, 30 times 4 is 120, 120 times 3 is 360, times 2 is 720. So 720 ways. Now, this is more complicated. What if A and B must be together? Now, what I would do is I would put A and B together and consider it as one object. So this object is kind of our AB as one block. And then you've got the rest of the books. So you've got C, D, E, A, B, C, D, E, and book F, right? So you've got your 6 books. Because these 2 must be together, so you're then considering the distinct arrangements of what's now 5 objects because these 2 must be together. So the number of ways these 5 objects can be arranged, as in moving them around the 5 blocks, is 5 factorial. So that's just the number of ways you can arrange the 5 blocks. But any one of those 5 arrangements, you've got to consider the internal arrangements of the A and the B. So basically A and B, it could be AB, or it could be BA. So remember, this fundamental principle of counting tells us if we have 2 successive things going on, different number of ways they can both happen, you need to multiply together to find the total number of ways. So for the internal arrangements of the AB, you've got this, it's basically a 2 because it's AB or BA, but it's also, you could think of it as a 2 factorial. Say there was A, B and C that had to be together, well there would be 3 factorial ways of that happening, and we multiply because it's the fundamental principle of counting. So that is going to be 5 times 4 times 3 times 2 times 1 times 2 times 1. 5 4s are 20, 20 times 3 is 60, 60 times 2 is 120, 120 times 2 is 240 ways. A follow-up question could have been, how many ways can it be arranged if A and B must not be next to each other? And what you could do then, you could potentially use the number of ways they can be together and the number of ways total there is, and you could subtract one from the other. So do watch out for questions like that.